right. Thank you. Hi, everyone. Thanks for having us here today. We're very happy to be here with all of you. And as the title of the session says, right, we're going to be talking about basically running Spark workloads at a large scale on Kubernetes. So before we start, let me ask you about how many of you are running Spark workloads? Spark? All right. How many of you are the ones who raised their hand are running Spark on Kubernetes? All right. How many of you are actually planning on using Spark on Kubernetes? All right. Hopefully, this session you find it valuable, and if in the future you are planning to use Spark on Kubernetes, you at least have the right foot to get started, right? So my name is Melendez. I'm a specialist solutions architect focused on compute. I work at AWS, and I mainly talk about Spot, Graviton, autoscaling, and much of these conversations are focused on Carpenter as well. I have here Ovidiu.
Hello, everybody. Happy to be here. My name is Ovidiu. I'm a senior specialist solution architect for the containers. I am dealing with working at AWS, same as Christian, and happy to be here.
All right, so we have a lot to show you, and we would like to focus on getting hands-on and show you how everything that we're going to be covering today actually works. So we're going to get started right now. So many of you might have been wondering how to actually, when you add a large-scale running Spark workloads, what are the considerations that you need to consider, right? So we're going to be focusing on the most important things, and we're going to dive into the technical details. Although we're going to be using, of course, EKS and a lot of AWS products, most of the topics and recommendations that we have today apply to whatever you're running Spark on Kubernetes. Okay. So why don't we start with Ovi?
Yeah. All right. Let's see first. All right. What do you need? Okay, when you have to manage and to have workloads with lots of terabytes, okay, on a lot of nodes, because you need the scaling that you have to put some measures in place, okay, for that scaling. Spark, okay, the first topic. Some of you, all right, okay, you know about it. This is an open source distributed computing system that is mainly used for the big data processing and analytics. And not only that, because it is widely used also into machine learning. Spark has sort of libraries, and it's usually comes as a cluster, okay, and has a standalone, but is built in with some limited functionalities. Hadoop Yarn, okay, I heard yesterday in the quiz, okay, about it. So this is widely used. And from like 3 years ago or something like that, it is a lot of interest because Spark was ported on Kubernetes. Because Kubernetes is the foundation that is widely used for any compute, and it's working obviously for the batch workload. And right now in our demo, we will see that we'll have the Spark installed with the Spark operator. Let's see a bit of internals, okay, high level, okay, what does it mean and how does it work? So whatever an application that is coming is submitting a Spark submit, okay? This is how it works. And this is going to the Kubernetes API server. Why? The Kubernetes API server, see this, obviously talk to the controller, talk to the scheduler, and then creates the driver pod, okay? This is on the Kubernetes data plane. Once the driver pod gets created, then inform back, okay, the Kubernetes API, I need some executors. And then the Kubernetes API schedule on the same data plane the executors. The executors, they are connected themselves with the headless service to the Spark driver. And once the connection is done, okay, then the task, it is started by the driver itself. And you'll see exactly this is how it's happening in our demo. But in order to make it work at scale, you need to do some considerations. Christian.
So yeah, when we're talking about high availability, auto-scaling on Kubernetes specifically, One of the projects that we recently released were 3 years ago at AWS. It's basically now an open source project called Carpenter. Now it's part of the core of the project. It's basically donated to the CNCF. And we also have Azure that has implemented Carpenter as well. So the idea is to continue using this as an alternative to cluster autoscaler. So if you are happening to run EKS clusters that need to scale automatically, Carpenter is a very good option. And in this session, we are not going to be diving too much into the project. But rest assured that we're going to be using this. And I'm going to dive into details when we go into the demo. But basically, when you have pending pods on the cluster, this triggers Carpenter, and Carpenter will launch the capacity it needs based on the aggregated capacity that these pods are claiming to keep working, right? Then when we talk about the capacity or the other challenge that you might face when running at large scale, it's going to be basically around compute and storage. So for compute, we already talked about that we're going to be using Carpenter in this case. And Ovi already talked about the components of Spark, right? So keep in mind that we have the driver pod, the driver of Spark, and we have also the executors. So you have two basically roles of the architecture in Spark, and this is where we basically recommend you to use Carpenter. Carpenter will basically can take care of providing the capacity or the compute capacity for the driver pods and for the executor pods. For the driver pods, because this is basically if you terminate that instance and if you get an interruption, for example, the job that is processing might be stopped. So in this case, we recommend you to, for example, use on-demand instances that you actually have running all the time. And for the executor pods, we actually recommend you Spot. Spot, it's basically a purchase model that is basically spare capacity that cloud providers have in their data centers, and they offer it at a bigger discounts. So if you actually want to run Spark workloads at a large scale, cost is going to be something that you need to consider as well, right? So when using Spot, this is a no-brainer. And when using Carpenter, and if you receive that interruption, because that is spare capacity, the only condition is that when we need that capacity for running on-demand instances, for example, you're going to receive an interruption. But in this case, what we have configured here, Carpenter, is going to make sure that you have the capacity all the time. That's why we recommend you to start with that as well. Now, we talk about the compute part, and we also need to talk about the storage challenge, right? So in order to have, depending on the workload that you're running on the job that you're running on Spark, you might have some need of running at a high throughput and a low latency. In this case, what we recommend you is to use local SSD storage, which basically is NVMe. And this is basically instance storage that is attached to the instance, that it actually comes to the instance. The only thing is that it's volatile. So if that instance is terminated, the data is lost, right? But the advantage is that you have like this, right? High throughput, low latency. And because there might be different instance types that might have 1 or 2 or even 3 disks attached as an NVMe disk, you need to configure. We recommend you to use RAID 0 configuration so that for the job, it's only as it will be only 1 disk or 1 unit, right? So we recommend you to use that. On the contrary, if your workload does not have those needs of running at a low latency at high frequency, we actually highly recommend you to use PVCs or EVS storage, right? So you have persistent volume claims, basically, and it's more dynamic. And the good thing is that if you're using this with Spot, for example, and you receive a Spot interruption and that node is terminated, when Carpenter gives you the replacement instance, the storage is going to still there. That's the only advantage, right? That's the main advantage of using this type of storage. So depending on the workload that you have, depending on the needs that you have, keep in mind this. But again, if you're using EVS or PVC claims and you're using Spot instances, you can actually run at a larger scale with a lower cost, right? So keep that in mind as well. Now, for the networking part, and this is basically the most common challenges that we see, the most common questions that we get from customers is around networking. And even though, again, as I was saying before, we're talking specifically in terms of AWS, this applies to other cloud providers as well. So what we recommend you is to actually configure a secondary VPC networking for the pods. So imagine that you have create a cluster, you assign some subnets, that those IP addresses are going to be used for load balancers or core stuff that you need to run the cluster. Then for example, for your workloads, for your applications, you can consider using a secondary subnet. So in this case, imagine that you have two subnets here attached to the cluster. You might have 65,000 IP addresses available per subnet. Twice the subnets, you unlikely are gonna have problems with IP addresses. Now, if you are actually modernizing and you are already prepared for using IPv6, we actually recommend you to use IPv6. We know that this is, even though we've been talking about IPv6 for a very long time, not everyone is ready to use IPv6. However, if you are open to use this, we actually highly recommend you to go into this route because you're gonna have less problems and also less configuration that you need to do into the cluster, right?
And there is one more bit that you need to consider it because you have the network, you have the compute in place, everything in place, but then you have to make sure that all these thousands of jobs, okay, they will be scheduled in correctly and, sorry, yeah, okay, and seamlessly. So we have in our demo, and you might consider an open source project like this Apache Unicorn, okay? Apache Unicorn, it's a batch scheduler, sorry. It is specifically made so that it has framework for the Spark and PyWorch. It is designed to handle mainly the batch workload. And the main feature of the Apache Unicorn, it is that it has the gang scheduling. That means all the applications, they are scheduled at once, all right? Not pod by pod, one after each other. So the Kubernetes scheduler, the default Kubernetes scheduler might be a blocker here, and that's why you might be considering this. In order for this to use it, it is very simple because you just use the annotations into the applications, and that will trigger using the Apache Unicorn, all right? It has also, you can assign queues and priorities, and more than that, it knows about the multi-tenancy. So different teams working on the same cluster can schedule workloads independently, all right? Okay, so we took the main, the Kubernetes, and the Spark, and everything what you need to do. But in order to create a, let's say, event-driven framework, yeah, okay, I want to talk slightly about the Argo workflow and Argo events that we're going to use in our projects. Argo workflow is a direct acyclic graph tag, okay, that it's orchestrator, that it's an Orphan engine, and it's the best way to run in other Kubernetes. Why is the best? There are also others, okay, on the market, but this one, it is integrated natively with the Kubernetes because it is installed using custom resource definitions and custom controllers, and the same, the Argo workflow and Argo events. And you will see that usually the Argo events can catch different, can have different sources, okay? Kafka, Slack, Redis, anything, all right? In our demo, we're gonna use the Amazon SQS. And the Argo events, once the event, once it is catched by the Argo events, then is passed to the Argo workflow that will kick the creation of the application, the Spark application itself. Okay. Right. So this is the blueprint that we talked about, and this is what you're gonna actually see in the demo. As I mentioned, a user will trigger a signal to the Amazon SQS, and then the Argo events that is running in his own namespace. Okay, so for this demo, okay, I use the EKS cluster, that is a Kubernetes upstream managed by AWS. And we have in this cluster Argo events, Argo workflow, and the Spark operator, okay? And we have, as you can see, in the namespace, we have Spark Team A namespace, okay? It can be, because I mentioned multi-tenancy, it can be many other teams, okay? So in this, the Argo events will catch this event coming from the SQS, and then it will pass that message on the event bus, okay? Because it has an event bus. A sensor will see that that message that is happening in there, and it will create a trigger. The trigger in this case is the Argo workflow, okay? And the Argo workflow then will create the Spark application itself. When the Spark application is running, that will create, we'll see the Spark driver pods, and the Spark driver pods, as I mentioned, when I described the Spark on the Kubernetes, it will tell to the Kubernetes API, okay, I need some executors because the executors are the ones that are running the job, okay? And usually the Spark driver should run on on-demand instances, because if it is interrupted, you have to start the whole Spark application again, okay? But if then the executors, they are best okay to run on the spot instances. If the spot instance it's interrupted, doesn't matter because another executor will be provisioned. All right? Okay. So actually, this is what you're gonna see, and it will be like a live demo. Yesterday it was work. We like to live dangerously. Okay. So the demo, I encourage you to take this link because yes. Okay. Because this is where is the demo. The blueprint is part of the data on EKS project. It's an open source project, and in the data on EKS project, you will have different blueprints for the AIML, GenAI, data analytics, and also streaming. All right, the link will get you directly there. Okay, so now we finished with this, and we should start with the demo.
Yeah.
Okay. What we have here, we have a cluster. Okay, you see the cluster, and you'll see that we have 3 core nodes in there. Okay, that's it. Okay, because no application is running right now. And I will send a message, okay, and to the SQS, and that will trigger creating the applications, and you'll see there how the compute will be provisioned by the carpenter. Christian will tell you more about this.
Yeah.
All right. Okay.
So what you see on the top here, on the bars that you see, those are basically representing the nodes that are already into the cluster. And the bars are representing how much memory the pods that are scheduled into the nodes have requested, all right? Requested, not used. We're showing that because you'll see how it's gonna work very dynamically and very fast.
So I'm sending a message right now to the, here, to the AWS SQS. I'm sending a message. Okay. The message has been sent.
And this is when everything is going to start, right? Remember that we were talking about event-driven architecture, right? So we actually made the trigger right now, and what's going to happen right now is that Spark is going to start acting.
Okay, so you see already that I have a job that is started it. Actually, I can show you here into Argo workflow. You see? So I have a first job, and the first job will trigger another 2 jobs, and that will end also with another jobs. So this is, as you can see, the first job that I started it. We're going back to here, and a number of pods, okay, for the first job has been created, and also together here are, yes, okay, I'm not doing anything. Okay, you'll see an additional node. Okay, it's a spot node. I'm sorry you can't see the spot node because I had to zoom in a bit. And this is for the first job that has been created. Once this job, will finish, that will trigger creating another 2 jobs in here. See? And the one on the left, it is a Spark operator. The one on the right, it is a Spark operator P job. It is running on x86 nodes. And the one that is a Spark operator taxi job, it is running on ARM nodes, Graviton, as we call them, in AWS. And here, soon, you're going to see all these nodes running. So I'm going to be able, for you to see better these things, I'm going to the Spark TMA, because here all these nodes will going to happen. I finished, the first job is finished, and this node that is a C5D X large will be soon being cordoned, and the node will be deleted. So the node, see, the node had been deleted once the job has been completed. You don't have to pay, for provisioning nodes, in advance. And now the jobs that I was talking about, they're being created.
Look at how the nodes are coming right now.
Yeah, Christian, maybe you can tell me, because I see one, that is a C5D 9x large. Why do you reckon, it is 9x large?
So remember what I was saying before, right? When there are pending pods, Carpenter is gonna react on that. There are pending pods, and it's gonna aggregate all that resources that are pending to be scheduled into the cluster, and it's gonna do a bin packing. So imagine that it has together they are requesting a lot of memory and CPU. Carpenter is gonna look for the most appropriate instance type among the 7 instance types. In case of AWS, among 700 instance types that we have available. So it's gonna choose, if it's on demand, it's gonna choose the cheapest one, the one that has the lowest price, and the instance type where less resources are wasted, being very efficient, right? And if we're talking about Spot, it's gonna go and look for the spare capacity, the pools or the instance type that have more spare capacity, but at the same time are the cheapest one. So again, the focus on Carpenter is to be very optimized, and you can see there that is actually reserving 87% of the capacity of the nodes, right? Depending on how you have configured the nodes and the cluster, it's gonna launch one instance or another. So if we go back to the how we define this, you actually saw how fast the nodes were provisioned, right? As soon as there were pending pods, you were actually seeing the nodes over there, right? And you can see here how we are defining this. With Carpenter, you basically have another CRD that is called, for example, in this case, it's going to be a node pool and an EC2 node class. So an EC2 node class is basically where you define all the subnets that you're going to be using, all the user data that you might need to launch the nodes for Kubernetes. And the node pool you have here, it's basically where you define all the compute requirements. So AWS is going to give you the whole universe of 700 plus instance types. And this is where you actually define, hey, that's fine, right? But I want to be using, for example, Spot and on demand. Carpenter will actually prioritize launching Spot instances unless the pod, the driver pod says like, hey, I want on demand. So Carpenter will respect that. And you actually have this for the ones that are for AMD. It's basically x86, Intel or AMD. And we have different instance families, C and R, and with different requirements of CPU. And from this, we're basically reducing the instances that we want to use and focus on the ones that we want. Carpenter will take lead in this and will choose the one appropriate. That's why you saw that Ovidiu, there was a larger instance type because it was trying to optimize that. And same thing applies for the Graviton, for the ARM architecture. You can see basically that we are using ARM, and it's gonna pick all the instances that are friendly or that can run on ARM architecture, which is basically what we call as Graviton instances or on silicon that we created for ARM. That's gonna give you a better performance and still can use a Spot, right? So you can have lower price and better performance when running at a large scale, which is very important, right? So,
yeah, let's see what happened with our work, with our jobs. I reckon they will be finished by now. Yeah, no, okay. The one that is running on the Graviton, you can see here C5G, G is coming from the Graviton, is running on ARM. And do you know that I mentioned the Apache Unicorn? And in here, I can show it to you. If I did a describe on the driver itself, all right, 1 second. All right, see, when they did the scheduling, okay, the scheduling was not done by the Kubernetes scheduler, was done by the Unicorn. Okay, here, because he did the scheduling. So he took all the pods that he needed and deployed it in once. He didn't do like one by one. Yeah, so this kind of concludes our demo. Okay.
you can see that the nodes are
the nodes are gone already.
They're not
because
needed
the job all the jobs are being are completed. Now I have the original core nodes. That was a live demo for you. Yeah, I think we're good in time, and we will appreciate if you have if you leave us a review, okay, on this link, please. All right, and if you have any questions, yes. Thank you.